We have the code. Let's test it. What should we call it? We had a couple of these simulations already. A live particle simulator. It's meant to be interactive. Particle live sim, so that should be a single HTML file. And we have two versions. And we will select one straight away. We have one from Gemini 2.5 Pro. Let's try that first. And then Gemini 3 Flash later, next. I can hear my fans going. Okay, so it's essentially live. The demo turned itself on too quickly. Okay, we need less particles or more particles. Yeah, let's do 500 or something. Let's do 500 particles. Can do up to 6 types. Wait, let's do 2 types. There's something not right with... Do I need to like restart? Right, no, it's actually working. You have 2 particles. Damping. The demo mode is starting too quickly. Particle values. We meant to select the colors or something. Well, I mean, it's working. It's doing it. Yes, it's doing the demo mode. It's got cells and membranes. It's not actually chases. It's actually similar to... Yeah, we did something like that before. It's also went through the same demo presets. Okay, the chases are nice. Worms. It's gonna form worms. I must have been looking at the same YouTube video when we developed something like this before. Well, when I say developed, yeah, this was vibe coded with AI, but this was vibe coded for now because we just gave the video and we have this preset prompt. It's doing sonification as well. I wish it was interactive with the canvas. No. And in theory, the demo should be off. Demo should be off. Damping is meant to be speed. That was Gemini 2.5 Pro. That's what you see right now. The sound is pretty basic, pretty annoying. Let's try Gemini 3 Flash. Okay, particle. Let's reduce the particle count. Because I can hear with too many particles. Attraction matrix. Colors represent forces between species. Red, repel, green, attract. Okay, it's actually doing something. I don't know which one is better. Friction. Ooh. What is the speed? Should be a speed of the simulation. Reset positions. Okay. Yeah, I would say generally Gemini 3 Flash did better. Yeah, it's kind of weird because in some aspects Gemini 2.5 gave a better... Oh, the canvas is actually interactive in this case. Okay, no, 2.5 did better. No, Gemini 3 did better. The canvas is interactive. That's what kind of we were looking for. Yeah, once it's fast like that, I cannot interact with the canvas in a meaningful way. Yeah, so not sure which one's better. Can't choose. Gemini 3 made the canvas interactive, so that's nice. Yeah, there's a problem of the too many particles causing trouble. Can hear my CPU doing extra work. Just not needed. And you can't get this emergent behavior like what Gemini 2.5 Pro did. Right, so this one, yeah, you actually have this like more complicated behavior. Yeah, so let's go with 2.5 Pro. Continue that output. You can change the model as well to something. Okay, can you actually explain this web application, or essentially turn the description at the bottom of the page into conversational overview? It's forming. It's interesting. What's called meiosis? Meiosis.
Welcome to this interactive particle life simulation. Think of this web app as a digital sandbox where we explore emergent complexity, how complicated lifelike patterns can arise from very simple local rules. You're looking at thousands of tiny colored particles bouncing around in a dark space. What are you seeing? Essentially, you are watching a microscopic, abstract world governed entirely by force interactions. The particles? They are just dots of different colors, or types. In the controls panel, you can set how many colors are involved, from 2 up to 6. The rules? The magic. The key is the force matrix you can click on in the controls. This grid defines how every particle type interacts with every other type. Attraction, green in the matrix, if a particle of type A likes type B, it pulls it closer. Repulsion, red in the matrix, if type A dislikes type B, it pushes it away. Neutral, black or gray, no strong interaction. By tweaking these simple attraction-repulsion values, you can suddenly get wild, organized structures that look like microscopic organisms, chains, or crystalline patterns, all without having coded those shapes directly. How to play? The simulation is running right now, but you can take control. Change the population. Slide the particles control to see the system behave with more or fewer individuals. Change the rules in real time. Force. Use the force slider to make attractions or repulsions stronger or weaker. Radius. Adjust the radius to change how far particles can sense each other. Smaller radii mean particles only react to their immediate neighbors. Tune the forces. Click on the cells in the force matrix in the control panel. This is where you become the god of this universe, setting the attraction or repulsion between every pair of colors. Try setting all type 1 versus type 2 forces to strong attraction to see them cluster. Demo mode. Hit the Play Demo button. It will automatically cycle through several fascinating force setups that create beautiful, complex, lifelike motions, like the wormlike structures or clustering you saw in the inspiration video. It even starts automatically if you leave the page idle for 10 seconds. Under the hood, the technical side, this isn't running on a heavy game engine. It's built with basic web tech. Canvas rendering. All the drawing happens directly onto an HTML canvas element using JavaScript. The cool glowing look is achieved by drawing transparent colors and blending them together using the lighter composite mode. performance focus. Since calculating forces between thousands of particles is computationally expensive, the underlying physics logic is designed to be fast, though it still slows down if you push the particle count too high. The compute shader videos you saw referenced in the source material use the GPU to massively speed this up, but this version keeps the core math running efficiently on the CPU within the browser. Density regulation. This is a neat trick to stop the simulation from just collapsing into one giant boring blob. If particles of the same color cluster too tightly, this feature subtly weakens their attraction, encouraging them to spread out into more stable, interesting shapes. In short, this application is a playground for exploring complex systems, showing how simple, local interactions, repeated many times, lead to surprising and beautiful global order. Feel free to experiment.
Right, well, there you go. This was description by Gemini 2.5 Pro. The code was created by 2.5 Pro as well. Can we check? There's something wrong with when does the demo mode starts and ends. Essentially, we might would it be better just to have a button for it for demo mode, and when the user interacts with the page, the demo mode should stop. So is that what's happening at the moment? Yes, this is not vibe coding, it's pair programming, isn't it? I don't know, what do you call it? What do you call it? Get Gemini, do we need the agent? Yeah, something like this probably will require an agent mode. We have an agent, look at it. Well, just trying to fix the demo mode there. And I'm not showing you the code, I don't think it's interesting. I mean, the code will eventually just be on the page, so you could look at it yourself. It's open source, you can download, mix, remix. Gemini, it's taking forever. API error. Yeah, we have GitHub Copilot looking at the code as well. Suggested the fix seem important for the parameters damping. We can test it right away. It's actually potentially better or worse. Okay, we'll read this out loud real quick.
This code snippet updates the velocity components of a particle or object named P1 in a physics simulation, likely part of a particle system or game engine. It applies external forces, Fx and Fy, to the existing velocities, P1.Vx and P1.Vy, then scales the result by a damping factor to simulate energy loss over time, such as friction or air resistance. This is a common technique in numerical integration for simulating realistic motion, preventing particles from accelerating indefinitely. Breaking it down granularly, for the x direction, P1.Vx, current velocity, is increment by Fx, force applied in x, and the sum is multiplied by 1 perms.damping. The same applies to P1.Vy with Fy. Perms.damping is a constant, probably between 0 and 1, that controls how much velocity is retained each update. Higher values mean more rapid deceleration.
And we had a different problem. Yeah, can we check if there's something wrong with the demo mode? Demo mode. When it starts and ends, essentially we might... Would it be better to have a button for it? Yeah, currently there's no button for it. Yeah, and when the user interacts with the page, the demo mode should stop. Should we change the code? Automatic model selection, agent mode. Gemini code assist just gave us a API error. And let's see if... Let's try to run a task opening a different app. For whatever reason, I'm gonna skip that. Just look at the code. Just look at the code. Okay, I'll have to finish in a sec. Let me know if you have any questions about this one. We're essentially trying to turn this video into an interactive web application, because whoever made this video, I mean, the video is great, but it's using whatever C++, I don't know what is it using, so it can only run locally. This one is all running in JavaScript, and the code is just on the page. So, and everything we do is eventually available on bionicchaos.com. Go check it out, provide your feedback. And yeah, most of the recent tools, the source code would just be on the page itself. Just go F12, find the source code, and we will read this, accept some changes, and we'll keep testing it. So this is more, we're turning it more into less of vibe coding, more into pair programming with AI instead of vibe coding. Yeah, so you have, like in this case, you have the 4 particle types, and this matrix is deciding which one gets attracted and which ones get repelled. So why it's so fast? I have to figure out why is it running so fast. I will have a demo mode for making videos. Yeah, so go check out the site. Let us know if you have any questions, and we will answer them next time, I guess. I'll see you next time. Bye.